Okay, I'll make a formal good morning to you at this point. This is Math 10, and this is an intro to mathematics. And to give you some idea of what we usually do here, we have a slide that you saw on the screen, and then we play music. You were listening to John Coltrane, and that was from the Five Spot Cafe. That was just released not too long back, and very enjoyable, laid-back music. Some mornings will wake you up, other mornings will keep you relaxed. This is just Monday, first Monday of the semester. The Intro to Mathematics is a course that I've been teaching for a long time, and by way of introduction, I'm Dr. James Curl. And I've been teaching this course for years on years on years. The materials I wrote, and you should have two books. The two books, one's this one, and we'll just go to the document cam there for a moment, Debbie, and we'll keep you hopping there. It's a computational review. And then there is a companion copy, and you need both of them. And coming off there for a moment, this is the selected applications. Now you notice one's a 5th edition and one's a 4th edition. And it has to do with the fact that I updated one more often than I did the other. But we're going to refer to these two books during the semester. And the intro course is a kind of pre-algebra course. It wasn't intended that way originally. Math 10 was not as a pre-algebra. And I started this course back in 1970-something. I think the first version of this was in 73. And I was interested in writing something for students who, as an adult, have a different perspective than they did when they studied mathematics as a child. Now, at this point, I don't have my own kids to think about as children. I have grandchildren, lots of them. My kids got very active all at once. The oldest is 9 years old. The youngest is just a year, and we've got 10 of them. That many. And one of them says, I'm that old. We do a lot of hand motion, okay? But the point being, as children, we get excited about going to school. I was thinking of this morning. We just came off of a summer session, and I'm not sure how excited I was this morning. I get up at 3:30 in the morning to do the work I do. So that means working on the computer, having some breakfast, reading the paper. My first lecture is at 7 a.m., so I was here at 6:30 a.m. And Sarah, my wife, also teaches here. And last night we barbecued a steak the last day before summer ends. So we opened up a nice bottle of wine and had a steak barbecue celebrating the last day of summer. And I wasn't real excited about this morning. Sarah was really distressed. She had to get up earlier. She doesn't like getting up before 7. So we had a discussion about what time we should get up this morning. She wouldn't get up with me at 3:30. Not even for 6 o'clock coffee. She wanted to sleep until 7. Her first class starts in 15 minutes. So she's got it figured out. But neither of us were excited about this morning. Now I'm excited. I've been lecturing for 2.5 hours, and I'm ready to go. Do you remember yourself as a child going to school and being excited about it? Couldn't sleep the night before? Went to school excited about it? What happened?
You lost it.
Why did you lose it? You're right, you lost it. How did you lose it? What happened?
Where did you feel that way?
You're weird.
I've been in school for 4 years.
Ah, that's why you're excited. And one of the reasons I'm standing here today is because I never really lost that excitement. I just kept going to school and eventually taught, and so it's just never been any different. I cannot hardly remember a time that I wasn't in school. But what happens to most kids? When does it change? They're excited about it. What happens? When do they lose it?
When the homework starts piling on.
Ah, when the homework comes, what grade?
Junior high school.
Sometimes sooner than that, okay?
Kindergartner who brings homework.
Kindergartner bringing homework home already. I've got some grandkids who are in preschool that bring homework home. What happens in school about the time you want to stay home and not go? Not just homework. What else happens? The multiplication tables. You're supposed to memorize the multiplication tables, the division facts, and you what? Overload. You don't know the multiplication tables, and so you don't want to go to school that day. It changes. Let me ask you this question. You go out to the mall, and you're going to do a little survey for me. You ask 100 people, do you like mathematics? How many out of 100 do you think are going to tell you they like mathematics?
3.
3? 10? Any more than 10? Depending on the group. But in general, I'd say somewhere between 3 and 10. Maybe 5. Most people aren't excited about mathematics. Now, we talk about mathematics at dinner, at breakfast, on vacations, and people tell us we should get a life. If I go to a social gathering, now we went Saturday night, our division, which is science, math, and engineering, all got together for a barbecue. We talked about mathematics. But if I go to another party, and we talk, people want to know, what do I do? Here's how I try to answer them. I bike a lot. I ride a bike. Oh, how much? Oh, this last year, 6,000 miles. I ride between 100 to 150 a week. Those are miles. Now this morning, I copped out. 3:30, I didn't go out and ride the bike. But I rode last night, and it's going to be a little bit harder this week with everything to ride my 100 or 150. So we talk about bike riding. And they tell me how they haven't ridden on a bike for a while and how they're going to do it. I take pictures, photography. Sometimes I share the pictures I'm taking, and they tell me how many pictures they've taken, and we talk about digital cameras, and we can go for hours. And I play guitar, and we talk about music. They want to know what kind of guitar playing I do. I don't do it very much right now, but I enjoy it. And all those topics, we can drink wine and talk about them, and people are friendly. And then they finally ask, well, what do you really do? Well, I teach. Oh, really? Where? MJC. Cool. Plan to go there one of these days and take some courses. Fantastic. What do you teach? Now, this is at the point just before they leave and talk to somebody else or go get a drink. And I say, I teach mathematics. Oh. Now, a couple things happen then. One is, never did like it. Or I'm not very good at it. Really? Mathematics? Ugh. And then they leave. Okay? Now, that's sort of the world that mathematicians live in. They're alone a lot. Or you can marry a mathematician and then you can talk together. And so this is what I ended up doing. There are a lot of things that I'd like to be able to do that I don't do as well as I'd like. Now, when I was a kid, my sisters played piano. I thought that was neat. So my mom and dad arranged for piano lessons during the summer. Baseball was played during the summer, and baseball started conflicting with piano. So I said, I want to play baseball. And my parents said, okay, you sure about this? And I said, yeah. Now my two sisters both play piano very well. Guess what I can't do? I not only cannot play baseball well, I can't play piano. And it's something I'd really like to be able to do. I listen to Elton John, and I really get excited. He plays it so well, and if I take lessons, I want to sound like him tomorrow. I play guitar, and I enjoy it, but I listen to Jimi Hendrix's old riffs and think, God, he sounds good, and I can't play that well. But that's okay. I make noise in the guitar and enjoy myself. I'd love to paint. I don't mean houses. Paint pictures. I love good art. I don't do it well. But if I didn't have a job and just had lots of time, I might try it again, but I don't think I'll do it very well. But notice, in any of those activities, I don't get down about it. Now, I left some numbers on the board. Debbie, we're going to go to some of these numbers because I thought they'll help me remind myself of what we talked about in the last hour. I have this number right up here. We teach Math 10, I've been doing it for a number of years. There are several of us teaching it. And usually about 4 or 5 classes a semester. There are about 40 to 50 students in each class. This is a small group because of the room. So if you look at it from the standpoint of a year, 2 semesters, roughly 400 students, and we've been doing this for 30 years. We've been teaching Math 10 to about 12,000 students in Modesto. That's a lot of people who've taken Math 10. Now, when I come to thinking about Math 10 and responses I give to you about mathematics, I'm referring to those 12,000 people who've taken the course. I've had probably half of them in my classes. So I've worked with over 6,000 people in Math 10. And they tell me about their background in mathematics, and here's what I think I would generalize. People who do not do mathematics apologize for it. Now, you don't apologize for not being Jimi Hendrix. You don't apologize because you can't paint like a Gauguin or a Monet or somebody who's very famous. You don't get down on yourself, but somebody says, hey, I don't do numbers. Can't do them. And you feel like in some way that you need to apologize for it. And yet if you walk out to the mall, you'll be darn lucky to find 5 people out of 100 who say, I really like mathematics. So if you don't feel real comfortable about mathematics or you don't like it very much, that's usual. There aren't too many people like me who spent their life with mathematics. So don't feel badly about it. What about mathematics, though? What is the advantage of knowing how to do mathematics? And why is it that you're a different person today than you were as, say, a 3rd grader? And a lot of that has to do with being an adult. When you learn things as a child, and maybe didn't learn them, it's because there were a lot of other things going on in your head. You may have been much more interested in other activities. Or maybe you weren't quite old enough yet to do what they were asking you to do. And so you turned off, and don't feel good about it. And then the worst thing that ever happened, this is soapbox time, okay? I'm on a soapbox. The worst thing that ever happened to your generation and the generation before is called a calculator. Because what did it give you license to do? Not think. Depend on the calculator to answer questions. And so I ask you, what's 7 times 8? I ask that in any math class I have, and I see a constant behavior. Reach into the backpack, pull out the calculator, turn it off, and then the question, what was that number again? And then they get the answer. That's independent of any class. That's very constant behavior. we don't try to do mathematics. And so this semester, I have a goal. First, we aren't going to use a calculator at the beginning. That shouldn't terrify you. Just accept that. And secondly, I'd like very much that you feel better about mathematics at the end of this course. I don't expect you to be in love with it, but to feel better about yourself, and understand that it's okay not to like it. And if you do like it when we're done, that's a payoff, but not expected. I do want to spend some time doing what students have asked me to do. When I first wrote the materials, in the first books that I did for this course, they didn't look like they do today. Students told me they wanted to see different things. The computational review was by popular demand. Students wanted to go through that and do it. The selected applications that I selected, most of them were by student request, not by, can you go back that way? Avoid the cameras. Okay, was not by my demand, but by what students wanted to do. You can slide through there now. Now, the whole goal in writing the materials was to meet those expectations of students, what they wanted to have happen. Okay? So, blame them for what you're doing. They made the choice of the things I wrote and rewrote and rewrote. Some of the drafts of these lessons went through 15, 20 different writings until it finally worked. So where do we start? Well, we start with number. Now, one of my grandchildren is this old. And you ask, how old are you? He goes, that many. You know what he's saying. You know what that means. We have different ways of doing it. So we're going to go to the symbols behind me. And here are the symbols that you can use for 5. These are the 3 most popular. This is the 5 of the Hindu Arabic system. This is the Roman system. That's the 5 that you see in the grandfather clocks. And this is when you're playing card games and you're keeping track of who's winning. That says 5. They're all symbols. We write the word 5. That isn't the way the world has always been. Question, if you were to pick up a book, let's say about the year 1206, a few years back, okay, getting close to 1,000 years, 800 years ago, 1206, okay, would you find the symbols we use reading a book then? And the answer is no. Now, the symbols we use have been called the Hindu Arabic symbols, okay, and they're right here. Hindu Arabic, 0 through 9. There are 10 of them. There are this many. So the word for 10 as a prefix is desa. Centa for 100, desa for a 10. Milla for 1,000. So we say it's a decimal system, meaning 10 digits, done by the Hindu Arabics. The first book written using those symbols, roughly 1206, okay, by an Italian. Leonardo, not Da Vinci, da Pisa, from Pisa, Italy. The Leaning Tower of Pisa. Leonardo da Pisa. He's known as Fibonacci. Fibonacci. He wrote a book called Liber Abaci. And that book used these numbers for one of the first times. And by the way, it set off a really negative reaction. In Venice, Italy. Okay, so Italy, you have Venice, that's where the canals are, and you go by boat from block to block. The canals of Venice, very romantic, unless you want to get from one house to the other quickly. You either swim or go on the boat. Now, commerce, business in Italy, they passed a law that you couldn't use these symbols, these numbers, because If you were bookkeeping, you could do what so easily? Cheat. You could cook the books. You could change numbers too easily. And so they passed out a decree. You will not use the Hindu Arabic numbers. And of course it didn't last, because this is a really neat way to write numbers. Very neat. Because you can use these 10 symbols to write any number you want. Now the biggie in all this, I'm going to illustrate with the numbers 2000 and 2006 is here, and then the number 206. Okay, just have a seat on the floor. This is Math 10 at the moment. Okay. So we have 2006 and 206. What's the difference between these two numbers? The 0, right? This has 2 zeros. This has 1 0. Now this is the year. This isn't. So we had a placeholder. And that was the big contribution of a 0. It always, well, it never, rephrase this. If you go back to Babylonia, where was Babylonia? It's in the news all the time. Babylon, Babylon, Babylonia. How about Iraq? Iraq was Babylonia. Going back to early times, way, way back, they didn't have a 0. So if you wanted 2006 or you wanted 206, you just wrote a 26. And you had no way of knowing. 2006, 206, 26. They all looked the same. So you might have had 206 sheep, 26 children, and it was 2006 BC. Before calculators. Now, the 0 is a placeholder. We know that when you look at place value, so that's the idea, place value, the first digit is how many ones, then how many tens, how many hundreds, and how many thousands. So you say 2,000 because that's the value of that digit. There are no hundreds, there are no tens, and there are 6 ones. Here, 6 ones, 0 tens, 2 hundreds. And so what I've written here is a place value chart. It starts with the ones, and you multiply by 10 as you go to the left. So you have 1, then 10. 10 times 10 is 100. You can use a shortcut, 10 to the second. Now we call this 10 the base. This is the baseball season. So we talk about base numbers. This is the base 10. I multiply by the base, so your next place value is hundreds. 10 times 100, 1,000, 10 to the third. And I can just keep going. So again, place value, ones, tens, hundreds, thousands. Now, Debbie, I want you to leave that just up there. I'm going to walk out of the camera frame, and I'm going to walk over to the document cam, and I'm going to open a page in the book that I want to go to, because we are talking about the first lesson, which is about the decimal number system, and we're looking at a place value chart. And this is sometimes awfully hard to create the way you'd like it. Let me get some light up here and get this where I want it. We're getting there. Okay. I've got a camera that's not wanting to cooperate. Eventually maybe it'll, no it won't. Okay, I'll hold it. Let's go to the place value chart. Now you can see the ones on the far right, then the tens, the hundreds, then the thousands, then the 10,000s, and you can see how that's all written out here. So here's your 10,000s, then the 100,000s, and then the millions and the 10 millions and so on. Now writing it out in words is pretty awkward. So as we come off there, we can write that with powers of 10 or just using zeros. So I'll show it first. Ones, tens, hundreds, thousands, and so on. So there's your ones place, tens, hundreds, thousands, and going on. Or with powers of 10 down here. Do it either way. But you need to know that we have a place value system. Now when I write numbers, I write 2006. I'm using positional notation. If I write out the number in words, you know how you write a check? 2006, so you write it with words. So this number, sorry Debbie, I should have telegraphed that better. But this number at 2006, you would write 2006. Now I don't use the and here because I like to use and for a decimal point. So if I'm writing a check for $2,006, I just write out this. And that's it. And then I'd write and no cents. This is verbal notation. This is positional notation. So verbal, and up here, positional. Two different ways we write numbers. And we do that all the time. If you write a check, you write it in words. If you write the date, you use just the digits, 2006. Technically, you should put a comma here, but most people would get upset if you wrote the date with the comma. But we usually put commas in. So 2006, positional and verbal. Now what's this advantage of this system we have? We can write any number we want with just 10 symbols. Let me move a little bit to the left a minute, Debbie. I'm going to go back to where I had these symbols here. These have become interesting to me because we are using them in different ways now. For example, 6 years ago there was a whole lot of talk about 2000, the year 2000. What was supposed to happen in the year 2000 with computers? They were going to crash. Why?
0. They didn't know what number 0.
It had something to do with the zero.
They reached the 2-digit date instead of the 4-digit.
Yeah, we had a 2-digit date. So if you had 97, it was a 97, not 1997. So when you went to 00, it was like going back to 1900 and forcing everything back 100 years. And it was thought that things would just do what? Collapse. Planes wouldn't fly. Banks wouldn't run. People actually did what? Bought emergency supplies. I bought wine. But most people bought emergency supplies and put them up because they thought they couldn't go to a store, they couldn't get gas, they couldn't travel, because everything would come to a screaming halt in the year 2000. So how do we reference this 2000? M&M. Remember the Millennium Candy? M&Ms? That was 2000. M&M. You don't remember that? How soon we forget. M stood for 1,000. In the paper last week, I saw a headline. Something about 5.8 M. And what were they using the M for? Millions. And if it's billions, they use the letter B. They're confusing things. So M is no longer 1,000, which it's been that way for a couple thousand years. Now it stands for a million in the newspaper. What's K represent? technology? 1,000. K is used in technology. KB, kilobits. We use this for 1,000 now. So we've changed some of the symbols. But the problem with early mathematics was you needed a new symbol for very large numbers. So M was used for 1,000. Okay? The big advantage to the Hindu Arabic system is I can get any number I want just by using those symbols. Now we live in a society, and I'm going to move a little bit now over to here, Debbie, if you will, where I want to focus on this word. It's been interesting. When I first wrote this material, there wasn't an internet. There wasn't a place called Google where you Googled things. So if somebody gives you an assignment, you run home, get in the computer, and Google it. Find out a whole lot of information, and I do much the same. The Google that you see on the internet was supposed to be this word. And a spell check didn't like this word and replaced it with that word. And that's how the company got named. What is a Google? Well, back a number of years ago, a mathematician was asked to write a book about new names for old, because the problem of writing about very big numbers has been around forever, as is the fascination. Do you remember the first time you counted to 100? Most kids do. They learn how to count to 10. That's when the grandparents get called. Okay. When my grandchildren can count to 10, I get a call from their parents. Dad! Keelan just counted to 10. And then they want to count to 100. By the way, sometimes they want to count to what? 1,000, but they get discouraged. Takes too long. What would be a name for a very big number? And it was answered by a child who was in kindergarten at the time. Now, Dr. Edward Kasner asked his nephew to name the biggest number that he could write, and it was a 1 followed by 100 zeros. And we named it a Google. A Google is a number. You thought it was a search engine. So a Google is a 1 with 100 zeros after it. Or, in powers of 10, 10 to the 100th. So this number, I think I have just enough room to sandwich that in, Debbie. 10 to the 100th. A Google. And by the way, named another number while they were at it. A 1 followed by a Google of zeros. And the child named that a Googleplex. It's a 1 followed by a Google of zeros. And by the way, that's not a 1 followed by 100 zeros, because that would be a Google. A Googleplex is so big, so very big, that if you started writing it 6 billion years ago, you wouldn't be done yet. Huge number. And by the way, the company headquarters for Google is called a Googleplex. I like that. 10 years ago, I'd talk about Googles and people would look at me like I was strange. Now, you've used a search engine and you just Google everybody. So if you want to Google somebody, you're using a number. 10 to the 100th. Okay. Out of this lesson, I expect you to be able to do 3 things. Write a number in verbal notation. And that's what we had right here. Verbal notation. And to write a number in positional notation. And then a third way of writing a number. We're going to use expanded notation. Now I'm going to go back to the book here in just a moment, but Debbie, I'd like you just to leave this here as I walk off camera. And what I'm going to do is come to another number at the bottom of the page. Here's my number, 507. Now that is 507 in verbal. And I want you to notice what I've done at the bottom of the page. I've written it 5 times 100, 0 times 10, and 7 times 1. That is called expanded notation. So here are the 3 forms on the sideboard for positional, verbal, and expanded. Now what expanded does is take the number that you have and you take each of the digits, multiply the digit by its place value. So I have a 5. It's in what position? Ones, tens, hundred. So I have 5 hundreds. 5 hundreds. And I have 0 tens. I have 7 ones. So I just multiply 5 times 100 plus, always a plus, 0 times 10 plus 7 times 1. We call it expanded. Now I could just ask you, what's the place value of the 5? The answer, 100, because it is in the 100s position. So you can tell me the place value without doing expanded notation. Now, I would be shortchanging you if I didn't talk about one other notation. Scientific. Scientific notation. Now, the number I have here is one that came out of our 7 o'clock lecture. I teach statistics at 7 a.m. Okay, and we have some big numbers there. Let me throw some of the numbers at you. We just this morning, for the first time, joined a network where we are providing the lecture on satellite connection, I guess is the best way of saying it, to 109 colleges in the community college system. Now, in reading from that website, that there are roughly 85,000 teachers, big number, and 2.6 million students, I think is the number right around that. So this morning, potentially, 2.6 million people could have been watching what we were doing. I'm hoping there weren't that many. That's scary. Most of them probably were asleep this morning, but a few people may have watched. When we say that we have a big number like this, we want a better way of writing it. So let's look at this number. In the stat course, this happens to be the number of people in the world today, roughly. It changes day by day. But this is 6,600,000,000 people in the world right now. The way we do that is 6.6, and I could write billion, or I could say times 10 to the 9th. Now this is scientific notation. It's short, very short way of doing things. So this tells you how many places to move the decimal. So it was 6.6, and then I move it 9 places to the right, and I get this number. By the way, of that many people, China has more than 1 billion. India has more than 1 billion. 2 countries out of 224 have 2 billion of the 6 billion. Just 2 countries have 1/3 of the world's population. And you thought it was crowded in Modesto. Okay. This last week, and this isn't Walt Disney, the big emphasis was on what? Pluto. What happened to Pluto? It was demoted. We thought it was going to be a planet and there was a group that got together and said, nope. Now, I've been told it's not over yet. Reason, only 300 people voted or something like that, and there were 2,700 at the conference. So one of the people who's a Pluto supporter said, it ain't over yet. Sounds like Yogi with the Yankees. But when you start talking about the universe, you have huge numbers, folks. And so they get written with scientific notation. And we will do a unit on large numbers and scientific notation. So we're going to come back to this. But I wanted you to realize that when we talk about notation, we have positional, we have verbal, and expanded. That's all we're doing today. Okay? Now, as I slide over here a little bit, I just wanted to point out this number is, I just picked this number out of the air. 3, 1, 4, 5, 9, 6, 7, 8. The first digits up to there were from a number pi, and I just threw a few more digits and no decimal point. When we write large numbers, we put commas after the digits, right? So I have 3 digits, comma, 3 digits, comma. And what I was showing here was how do we find place value? So when I see the 9, we say it's in the thousands place. So the place value of the 9 is 1,000. You could do what? Write a chart. Put the numbers in the chart, and you see the 9 is 10 to the 3rd, and that's 1,000. You look at the 4, and it is a 10 to the 5th, 5 zeros, that's 100,000. And you can give me place value. Okay. Now, just over my head on the TV monitor, you can see Google and 10 to the 100th. That's just another way of writing a Google. Now, what I'm going to do, Debbie, again, I'm going to walk off camera, just leave that there for a moment. And I want to walk back to what we are going to do, because I need to wind this down now. First, there's a review on page 5. And so I try to give you a review of everything we've done on each lesson. So we come back to the document cam. So there's your positional notation, your place value. It even tells you the page where you can find that information. So all the things we've talked about are there. And then you turn the page, and every day there's homework. Sort of like vitamin C. So we have an exercise, page 6, 7, and 8. And here's what I want you to do for tomorrow. Using the book, I want you to write in the book and do the exercises on 6, 7, and 8. Now there are answers you can check, but you need to make an agreement with me. Don't check the answers until you've done the work. So on page 9, there are the answers you can check, but don't check those until you've done the work. And there are a few more other agreements I need to have from you. 1, don't use a calculator right now. I'd like you to get confident without a calculator so you feel better, that you feel like you can do things in your head. That's important. So you're going to do the exercises, 6, 7, and 8. You're going to have it done. You don't turn it in, you just have it done. Then you turn to the back of the book. And all the way back on page 183, 183, review test 1. Without calculators, on your own, do all the problems in this review test. On the page, put your name on it. So again, you're going to do the problems on the page, put your name on it, and you're going to turn it in tomorrow at the beginning of class. That's your first homework assignment you turn in. I want those problems done without a calculator. I want those problems done to represent work you can do on your own on the review test. No time limit, and you can check material in the book and look at it. But I would prefer that you do that on your own to try to make sure you can do that. You can work together on the exercises, and you may compare notes on the review test. But I want you to do the work on your own. and you'll turn that in, writing in the book, tearing it out of your book, and turning it in to me tomorrow. And that's what we're going to do day after day. We're going to spend the first half of the semester going through this computational review. Now, on Thursday, we're going to spend time in the Orange Book. So Thursday, I'm going to work on the first unit called counting. And we're going to count in a base different than 10. Now, as a child, you did something your parents got very excited about. You counted, and you went 1, 2, 3, 4, 5, 6, 7, 8, 9. They got excited. When you said 1, 2, 5, 4, 8, 6, 10, they weren't pleased. We're going to try counting in a different base and see what it means to live in a digital world